So this is the first initial commit, and first few things that are happening with the Coco dataset and within Detectron. Uh, so uh, this is actually right now in the dev branch only, not even put it in main. So this is the environment that I'm using. This is the dataset Coco, and I'm actually focused on the eval part of it. I'm going to come to this. Haven't really started doing the eval right now. Just initiated, not even initiated the training and all actually. So found this good this thing. I don't know, blog post or whatever it is. So he's basically gone and explored the initial structure, the file structure of the Coco dataset. I haven't got my training data down yet. I just have validation. I'm just playing around with validation because training is a large file. I might get that down, might not get that down. I don't really think so. I'll be training on Coco. Just wanted to understand how this is different from some of their uh, other other things that I've been doing with Coco. Just wanted to understand that, and especially in Detectron's perspective. So what is important for us is this basically, how the Coco annotations work. So this is basically the area of the bounding box, whether the object which is being shown, is that class part of the crowd, not part of the crowd? Is it like a background class, yes or no? Then what is the image ID? This image ID is usually some kind of extraction from the actual image file name, and then the bounding box of the object. So the bounding box can be multiple. You can have multiple objects in this, right? There is a category ID. So what class is this 58? If it is a 2, then it's a cycle. If it is 58, it is something else, and things like that. So he's played around with the code and trying to show us the JSON file and what exactly is the structure within that. Uh, then he recommends that we use the API, and the API makes things simple. Of course, the API makes things simple. So this is just some initial imports for Detectron and Torch, just making sure versions and everything is okay. Mismatch between Torch and the CUDA version, this can create problems. So this we have to be careful about. Uh, it will complain saying that the CUDA version is different from what the Torch version was and all that. So you can then go to the Torch site, and then you can do a Conda install of that. So they've given specific strings over there which you can use later on. So this is just the logger for Detectron. And this is the Detectron model zoo. There's a model zoo.py file over there, which has instructions. Basically, you go from config to model zoo, and from model zoo you end up getting specific paths for models that you want to get downloaded, and that happens through the config. Um, then there is this default predictor. You always create this predictor so that whatever model you have trained during validation, you can do that. And then whatever is the output of this predictor is usually passed to this visualizer. You can end up visualizing your predicted and ground truth, both bounding boxes on your images. Then this is for registration, metadata catalog and a dataset catalog. This is used for dataset registration. And here we are just experimenting with some image, and we're just saying, okay, fine, we are just looking at this image, but I have already deleted this, so I'll just comment this out. This is the initial annotations how you're getting. So this is the validation file. This is a train file. Train dataset I have not downloaded, so I really can't use this annotation file, even though I did download. Train dataset I will download. I have not done that till now. So okay. Then this is just that experimentation that he has done. David has done. Just to see as to what is there within that annotation file. So even I did that, but that's okay. We can leave that aside now. Coco API. So basically created a object which is of class PyCoco tools, and then we want to get category IDs for uh, images basically which have that category called bicycle within them. So then we will get image IDs with that category ID. So that category ID is basically two. So if you run this line of code, it will give you two. Similarly, you can have some other objects listed over there. Maybe you can have motorcycle or God knows what. There's almost like 50 plus classes in Coco. So then it will give you those image IDs. You get the first 10 image IDs over here. You save it into another list. Uh, and this is what that list looks like. So you get 10 image IDs out of the validation set. You get about 10 out of the earlier training set. Then okay, so I just noted down separately, but you don't have to give it this way because this guy is given some excellent code wherein it goes and fills the zeros. If it is so, it's supposed to be 12. It's supposed to be string of length 12. So if I just give this 9377717, it will go and z fill the rest of it. So then okay, imports for plotting using pill and matplotlib. So then just iter over the that list which we got on top here, 10 files, and for every this thing just give that image ID basically to this image IDs function, and you get annotation IDs out of that particular image for category ID bicycle, and we can print that. Then again just move it into a list, and once it's moved into a list, this is where your validation images are saved. Basically the local file path hard coded over here. Then you just get the image name. You do that zfill and open that image, create your matplotlib subplot structure, and so there are actually no subplots, but again just created that. So then iterate over that list for each and every image and plot the bounding boxes. So what are we plotting in the bounding box? The top left, the top right, the bottom left, and the bottom right. So that is what we get in the bounding boxes. We get four annotation values, and that's it. So after that you can see those plots. So that's the code, very simple. Yeah, and I'm just calling it det2 underscore 1pi. There's nothing done right now. The absolutely first initial very exploratory kind of code. Yeah, so this is what it is. So you see this street, this thing, that 3-4 bikes which are there. Some of them in horizontal, one is almost vertical in the sense facing the camera, but you can see all the bikes have got bounding boxes around them. Similarly over here, I think there is only one bike in the entire scene. So yeah, and here there are a lot of bikes. All of them are almost, even the far off ones on the beach, they are also getting identified. And most of these are, I think, getting identified. I'm not spending much time on looking at all of this. And again, two bikes and one bike, and I think that's about it. Oh yeah, more bikes and one bike in the corner. So fine. And this one I couldn't even make out earlier. I thought, yeah, so there is a bike. So excellent this thing, and obviously Coco dataset is trained on a very large training set, so I doubt if it will miss anything, and most of these are coming through. Okay,